Okay. Hi, Chandan. Hey, Ranbir. Good morning. Hello, everyone. Good morning. So last time we have covered about mostly on the foundation material side, and we took one problem as well. Just let me know if I am audible properly because there are some issues as well. Could someone acknowledge over the chat? Okay, thank you. And I will present my screen. I'll present a slide with you. Meanwhile, I think this time we have less attendance. Probably people will still join in next 10 minutes. But let's start, get going. Are you able to see the screen? I mean, the slide only I have shared. Okay, great. So we covered about the batch processing. We covered the whole system that we have as part of batch processing and where exactly it fits. We have also seen the problem where part of a system was batch processing, but some other parts of the same system were online and stream processing. So here the idea is that whenever interviewer present you a problem, you have to identify which particular area you have to focus, and accordingly you can proceed with that. So if he wants you to design something called full Instagram, and definitely it's not something depth oriented unless he talks about very specific thing in the system. Else you can always consider it as online system if not given, but if he wants you to focus on some part of the system where you have to deep dive, you have to drill down, and it's only just one or two couple of microservices that are required, and mostly the algorithmic part exists, then it's like most probably it's going to be the batch processing. Okay, and accordingly you can plan. Then you have to consider the points more into scalability, more into estimations if required. Yeah, so the idea here is that like between if you compare online versus batch, you have to explain a bit more. You have to go deep, dive mostly into such kind of questions. But in breadth oriented, you can just simply touch on few things. Maybe some little bit of discussion would be there, but not that much deep dive is required in these. But yeah, we are going to cover all the everything that exists. Okay, so here we will not be going with the foundation part. If required, we can go a little deeper into that. But here we will simply start with a problem that we have. So today we are going to cover the topic called like graphs. Okay, so you have seen the examples of LinkedIn, Google Plus, and some other social networks as well, where we have the connections and we actually have the graphs. So people are connected to other people, and those people again are connected to thousands of their connections. Okay, they can scale to millions of connections. So connection wise, there can be a lot many connection that can exist. And it's like whenever you create a new connection, whenever a person creates a new connection, most probably it's not something that happens on the go. So if somebody has created a connection and their connections, they wants to check whether like they wants to get the notification immediately, then this is not going to happen. There is a connection like action, and then there is some pre-processing. Those actions will be stored and they will manipulate some data behind the scenes. They will be structured, they will be stored into the database so that uh, online queries, they can fetch the result as soon, like as quickly as possible with minimum latency. Okay, so this is what like batch processing is. You are doing the task and through some service behind the scenes. It's not happening on every call, but it's happening once or as a kind of scheduled job, and it is making the life easier for online processing. So here Considering connection, you use LinkedIn and you have a connection. Say you have hundreds of connections, then out of those hundreds of connection, one of the connection is sharing some more connections. No connection is common between you as well as their connection. So that means all the connections of the person that you are connected with are second degree connection to you. So and so on. So direct connection is first degree. Uh, Connections of the direct connection are the second degree, and it spreads like that. So let's see further. So we have to determine the degree of connection between two members in a social graph. You got the idea what a social graph is. So API wise, like we are structuring the problem in terms of what we have in the APIs. So maybe there are three different APIs with three different complexities. So first, getting the first degree connection given two connections, and we have to come up with Boolean logic, Boolean result whether they are first degree connection or not. Similarly, for second degree, we are always given two connections, and we have to find like if asked, we have to find whether it's a first degree, second degree, or third degree connections. Okay, so looking at the problem, we came up with such kind of functional requirement. If you have any question, just let me know. I'll check whether there is anything on QA. If you need more explanation of the problem, like problem was simple enough, so that's why I simply got started with the functional requirements. Okay, so problem is simple enough. We are given few connections, and you just have to find whether it's first degree, second degree, or third degree connection or not. Okay, so what about the non-functional requirements? Could you let me know over the chat if you can, what are the what could be the non-functional requirements that you may think of? Anything? It may be anything, like starting with it's the service is available. So Anurag, Arijit, yes, yes, Ranveer. Scalability, service should be scalable. Number of users, reliability, Chandan, yes. So Manjinder, what about a number of users? Like what exactly is the point here? Like it should scale for the number of users that are available, or do you just want to know what are the number of users that we have? Uh, by default, as I said, that you can always assume like figures like 10 million or 50 million. It's perfectly fine if you have no idea, else you can verify with the interviewer. Okay. So here it's taken as 600 million because it's the data from LinkedIn itself. Okay, as of 2022. So yeah, so non-functional requirements, maybe the system should be available for 600 million users. Maybe some of them would be active, some of them would not be active, but total number of users would be, you can consider 100 million or 500 million. If you have no idea, you can even start with 10 million. It's perfectly fine. Average number of connections. So by default, like because this factor adds the complexity. What is the number of connections one user have? So if every user is having the connection in millions, then finding the connection would be too difficult. By saying that, I mean, even if we apply some brute force would be given to users. We first find the list of all the connections of user one, go into every connection. Like first we'll check whether, so let me like annotate here only. So maybe it would be easier. So let's say this is user one. Let me know if you are able to see the annotation that I am doing. So this, thank you. Thank you for confirming. This one is connected with many other users, 4, 5, and like so on. It would be 1 million. Let's consider the worst case. Every connection have that many number of connections. This user again connected with like 6, 7, and so on. Again 1 million. So what brute force we come up with? Given user 1 and 7 is first degree is the question, and what we will do, one will have some connections. Iterate over each of the connection, whether this is 7, whether this is 7, this is 7. So up to 1 million, we'll check this is 7. No, then we go with indirect connections. So let's say it was 2, 3, 4, 5. We expand 2's list. So it would be 1 million users. We'll check whether this is 7, this is 7, this is 7. So again, 1 million. Finally, at some point, say for 5 or 6, we got that, yes, it's 7. So we say that it's not a first degree, but is second degree. Okay. But the complexity uses the number of connection it have directly proportional to the time taken by this algorithm, by the brute force algorithm. So that's why this considering the average number of connection is important here. So that's the only reason we are considering that. And there is no limit of the connection, because up up till some limit you can have the followers, but connections you can make any number of connections. And we are considering the fact that no limit to the number of connections, because we have the use case and the solution for that. The way we will store the data into the database will simply emit uh, this issue of like storing unlimited number of connections. That's why in every problem which is related to followers or something like that, connections, followers, we can use the solution from this problem, and we can always use unlimited number of connection use case. Okay. Considering here each API has to be fast, and it should be like it should take 100 like milliseconds, hundreds of milliseconds in this figure. Okay, not important, but if you are like if you have exposure of multiple micro solving the multiple system design, and you think this is important figure for depth oriented, I feel that sometimes, like not frequently, but 20% of the times, they may give you some this kind of figure, and you have to consider this fact. Queries per second or the request per second is given. It is 40K per second. So because we will make use of, we know that number of queries are going to be huge, because the number of consumers are very large in number. So that's why query per second plays important role here. In some of the online processing system, we might not have considered this, but here this is the only service which is like one of the service which will be handling all the load. So it's important here. And queries per second would be the key factor here to go for design decision of scalability, whether we should be scaling or not. Okay. So I think Manjinder, you have one question. API speed must be derived from other fact, let's say number of requests. Speed, actually, this is something that should come experimentally. Generally, the range of any API, like servicing any API, it range from like 20 millisecond to 500 milliseconds. So uh, generally, this is the figure that we have. Okay, but it completely depends on the algorithm that we use and the kind of data that we are dealing with. So maybe this figure, if it is given by the interviewer, then well and good. Otherwise, don't make assumptions. Like no need to make assumptions, because this discussion would not be like that longer to consider these facts and come up with your solutions. But yeah, see, like if given, what you would do. Okay, and going to the next slide. Oh, let me clear. Okay. So microservices. So what do you think? What other microservice can be? Basically, we are given very specific problem to find the degree of connection. This was the requirement. So that's why only one microservice that we came up with. Maybe there can be the one that was reading about the connections, the service that was reading about the connections. Like one service can be like it can be processing service, one can be the view service. This would be the online part. Processing service would simply collect all the data. It will get the data and it will somehow manipulate this data and like restructure, transform into some other form, finally stored into the databases. Okay, so this service is the thing that we are interested on. So that's why it's like depth oriented, and we don't need to discuss the view part of this. We will discuss about the algorithm, but that is not required. So single service here, directly jumping into like in the last session, we came to this point a little later after explaining everything. But here, since we have single microservice, we can talk about uh, like what the service look like, what are the internals. It would be three-tier application, cache, and storage. We look into cache, like why cache, but application and storage definitely required because we are getting lot of data, lot of connection data, and we would have to like transform this data into some other form so that these APIs are going to be fast enough. Okay. So coming to like what could be like how would we solve this first degree, second degree, and third degree like APIs or the logics, how would we implement that? So one of the thing that I have discussed is about like brute force. We'll simply dig into one's connection list, and then we will think about like think about its connection, and if not found, then we will go deeper and deeper. Okay. So what other thing that you may have? Do you have any idea like what other logic that we can implement here? Anything? You can share anything, like whatever comes to your mind, like as a solution. It may be some algorithmic, just an idea. Okay, Ranbir, I cannot hear you because you are not unmuted. Maybe you can try now.
Okay, so it seems like uh, BFS problem that will be
Okay.
more efficient because we can check level by level. So we may find result in first level, so we don't need to go to second and third.
Mm-hmm.
If go for depth oriented DFS, then I think we need unnecessary traverse most of the part of the tree. So I think BFS is more efficient.
Okay, BFS.
Yeah.
Okay. What others says? Any other idea? Anyone wants to be unmuted? Just let me know. I'll. Okay, Pradeep, can you tell about that?
Hi Prashant.
Hi.
Actually wanted to see the problem. I just 5 minutes late, so I missed that first page. Can you show that
I will explain.
53 slide ones?
I will explain here itself. So the problem here is that uh, you are aware of the system where we have the connections. Okay. So if this is user one, this is user two, user three. Consider the use case of social platform like LinkedIn, where user one can be connected. It's bidirection. Like U2 is the connection of U1 and U1 is connection of U2. So there is no direction. Okay. So this is called the first degree connection. Okay. And this user is connected to U3, but there is no such connection exist. Okay. So, so U1 and U2 are first degree connection. U1 and U3 are second degree connection, U2 and U3 are first degree connection, and let's say we have U4 as well, and somehow this is also connected to U2. So what we say, U2, U4.
First
Oh,
degree,
this is first degree. U1 and U4, what do you say that?
third degree.
No, it's a second degree. So this link and this link, first degree and second degree. Okay.
Yes,
But
yes.
but somehow like this didn't exist, then it would have been first degree, second degree, and third degree. So then it would have been a third degree connection. So this is the problem where we are given, like it's given, we have the platform and we have the data. We just have to store it simplified so that we can answer these three API calls efficiently. So is it first degree given two users, user one and user two? It's given already. So is it a first degree? Is it a second degree? Or is it a third degree? Okay, so we have to find the degree connections here. This is the problem.
Yeah, got it now. Thanks, Prashant, for explaining.
Okay. So any idea like how we can solve this problem, how we can simply find the logic, derive the logic so that we can answer these three API calls?
I think we can go with the depth first. It's like graph problem.
Depth, okay. So could you explain like how exactly,
Like
like
we know
what would
our
be the
start.
traverse?
Yeah, so we know our start and end actually. We are given two nodes. We just find out the degree between them
Okay.
from the
Okay.
start.
Yeah, I got it. So maybe Abhishek, you wants to talk about that?
Yeah, so what I'm thinking, why are we even thinking here? Maybe I'm wrong, of breadth first or depth first. Because if I see the user one, we can just directly go to his already connected links and mark them as a first degree, and browse all those connection which he has and his friends or connections, and then mark them in the second degree. So it's like a it's not you're trying to make the connections are already there, you're trying to fix the degree. So
Hmm.
in a way it's a breadth first search, it looks like, but actually it's not scanning all the users to create the connections. Its connections are already there, you are just trying to mark the connections with the degree. So then it's just like traversing your first uh, linked list, then second, and then list of list, like that. So that's what my assumption is.
Hmm. Okay. Yeah. I completely get it. So we are already given like connections. So let's say
Right.
if
So
we have
we
million users,
first,
all those
uh,
million users are
yeah,
having some connections and we already have those connections.
right. So I think it's already there. I mean,
Yep.
connections are already there. You just need to have a what you say, just degree defined. So you just go and list of your friends, and then friends, and then mark them as a degree.
Hmm. Yep. Right.
Yeah. It's a sort of breadth first, but not fully, like you're not scanning all the users. You're scanning only the given list.
Yep. Right.
So this is like backtracking, right? Maybe.
Yeah, we can
Yeah.
say like a sort of breadth, but in that
Yeah.
we are not traversing all the users basically. You have already defined list. So,
Correct. Yeah.
Hmm. Okay.
so actually, even if you go depth first or breadth first, doesn't matter actually in this case. If you see, you are gonna scan all the users which are there in the list and list of list. So both should be same because you have a finite number of people to traverse, and nothing to be fined. Like all has to be traversed.
Okay. Yep. Makes sense. Makes sense. And any other idea, like I want to hear something more. Maybe some simplification might be possible.
Okay.
Maybe anything. So Kanan, I think you're saying, can we use graph DB? So can you talk about that more? I'm not much aware of graph DBs, how we can solve this problem using graph
Um,
DB.
okay, I haven't personally used GraphQB as such, but
Mhm,
there are databases which are specially meant for such use cases wherein there are multiple nodes, nodes have properties, and there are associations between nodes, right?
mhm,
It might internally use one of these algorithms or some derivations of it, but it basically solves the problem of we writing this from scratch and thinking about the data structures we use in memory, how we handle load balancing, failover, and all of that, right? Um, Given we can use a platform here, these uh, technical implementations, I mean, we can focus more on the business logic than on the implementation.
Okay, so but here like we wants to know what is the implementation, how would it be? Because on the first hand, we need to make it bit faster,
Mhm.
right? So that is what like want to discuss here.
Right. So the base implementation, it looks like it is going to be some sort of a topological sort or a breadth first search. So the key is when do we do it? I mean, when do we try to compute if two nodes are associated, or we pre-load the complete friend or linked graph right
Mm,
in memory, and then in that case, I mean, the response times will be faster, but there is a pre-processing time where we will invest, and we should come up with how we maintain the cache, how are we distributing, do we need to shard it based on users and things like that.
okay, so we will discuss like how exactly we'll shard this data, but algorithm wise, probably we can try something like this. So I don't know why this annotation go away. Okay, so here we are like I have described about like how the users were given. So first degree is something like lookup only. Okay, we are just looking at user one's connection list, and we are finding whether user two is present or not. Given that user X and user Y, they are first degree or not. So let's say this is X. So we simply look whether like this Y exists here or not. Just look up. What about the second degree? So it would be like maybe we can make use of something else so that so we are given user X connection list, which is here, and user Y's connection list is given. So what happens like in case of mutual connections, what happens? So user X, suppose they share a second degree connection, and user Y, they will share some user Z, right? This means that this would exist here, user Z, and this would exist here, user Z. Okay, so would be common, right? Agree to that? So what we can do, like one simplification could be like instead of going and pre-processing everything, we can simply look up into this list and this list somehow, like because we have collected this data and we know that it's sorted already. Okay, so what we can do, we can like two pointer approach we can use in here. So starting from here and here, we'll simplify whether they are equal or not. Uh, add if they are not equal and say this one is lesser than this one, maybe probably the ID. Move this pointer above. Now again they are not equals. At some point, like where we see that this number is greater, then we will move this pointer and it would reach here. And finally, we have to increase this one and we would reach here. At some point, we would have this node common. We'll find that using maybe like optimal approach, say what we can say, the algorithm called like instead of linear search, we can go with binary search. Uh, Using that algorithm, we can at least find pretty much easily, like optimally, whether they are connected or not, given the connections list. Okay. So one optimal approach here, like algorithm wise. So first degree is fine. Second degree can be a two-pointer approach. And what would be the complexity here in this case? For first degree, what would be the complexity? It would be order of something.
Order of 1.
Order of n it would be, right? We
Oh,
have,
okay,
If we
depends
are,
on whether it's a list or a map.
then it's
yeah,
not order of n. If it's binary search,
yeah. So considering list here, and it would be like instead of n, it would be log of n. Okay. We just have to find one like user ID here. What about the second degree connection? We are iterating two of the list now.
Is it n square? Order of n square.
Order of n square, and what other says?
I mean
Okay,
n log n,
we will come
because
back.
again you will do
Okay.
the binary search on the second as well,
Hmm.
because so maybe n log n.
Okay, and login is this. So we'll come back to the complexity. Let's discuss first about what is the third degree connection, like how would it be? Probably we can make use of second degree connection here. So if given user one, user two, and we wants to find some other user. So probably all the connections of user one, sorry, it would be three and user four. We'll apply, let's say we have to find user one versus user X. We'll apply all the connection with user X, whether they are first degree or not, second degree or not. Okay. Instead of implementing some logic for third degree, we will simply iterate to all the connection of user one and check whether U2 and UX, they are second degree or not. So that would be algorithm for third degree connection. Okay, any question to that? Like this, the algorithm, if somehow you're asked about it, how would you implement? So these kind of algorithm that you can discuss about. Complexity wise, sorry, okay, drawings are already gone. So order of like log n we have, and two pointer approach we would have. There you cannot, like for lookup, you can have the binary search, but for two pointer approach, you have to sequentially process those. So list one, you would sequentially look into all the elements. List two, you can simply have to look to all the elements here. So n and like 2n would be, it is going to be order of n only. So is from n square we have reduced to n, and this is log n. And since we are making use of like all the connections of user one and checking whether they are connected or not. So first we have to iterate all the connections, which is n. Then again we have to apply the second degree algorithm, which is also n. Okay, so it's come out to be n square. Okay, this one would be very much. It's not optimal. We will have to check how we can optimize that. But on paper and given a very short problem, like you have to solve it in a single machine, and scalability is not yet in picture, then these are the algorithms and these would be the complexities that you would use. Okay. So the scaling the algorithm would be the second part. So we are able to solve this problem for shorter data set, maybe on single machine without scaling using these algorithms. Now we have to think about scaling this problem. Okay, so we will discuss about like given the non-functional parameters here, we'll have to decide like what would be the key factor to go with scaling this. So storage, definitely it is something that we have to consider, because if you generally consider a use case, 600 million user you have considered, and let's say on an average 10% are active users and they are making connections every day. Like in a day, they create like hundreds of connections. So the data created would be huge, and the queries throughput, these would be something for that like maybe one server may not be able to handle the storage or like servicing the APIs. It would be too difficult. So in that case, storage is something that forces us to scale the solution throughput, API latency. We will take a look on that. Any hotspot that we can think of? Geolocation, definitely, because it's a global website. So any problem that is given which is operated globally, we can consider scaling for geolocation. Like unless it's like very specific to particular region. If it is used globally, then we have to consider that for scaling. Availability, yes. So we'll look into hotspot if any. Now coming to the calculations, somehow we are given like some calculations we are given. So we some assumptions we have to make. So API one. So we have different API and we are given the time taken, like the complexities are given to us. So considering 10K requests per second, API 2 would have little lesser hits, maybe 5K. API 3 would have more, like it would again have the usage which is very limited. So overall, it comes out to be like queries would be something like 17K per second, adding all those. This is experimental data, number of APIs that we are given. Experimental data, maybe you can consider any number, but you have to like think about whether they are like they should be in the figures of the complexities that we have. If one is n square, other is if one is taking n, the other is taking n square, then definitely you should consider more time, more number of queries per second for the time for the complexity which is like which have the higher complexities too. So in the same figures, you can consider the data as well. Like two times two would be four, so 5K per second is something that is like somehow they are related, like as per their complexity they have. At least it should be more than that. Okay, completely experimental data. Latency. So we will also add some logic where what is the usage and what is the actual active users that they are using this data. So weighted average we have calculated, maybe like weighted average is something that on an average how much time it would take. So 50, 90 and 99 is the time taken. API 1, API 2, they are given 10, 20, like in the milliseconds, it would be something like 10, 20 and 30 millisecond. Overall, the system is taking close to like 70 to 80 milliseconds, which is the consideration around 100. So what we are calculating here is that single thread for any, so we are considering the processing time here. Okay, so whenever you calculate the time or you do the calculation, always go with seconds, like, because most of the figures you will get in seconds. So convert a millisecond into seconds. So overall, you have to divide with 17K per second. It is there. So 10 milliseconds, you have to convert it into seconds. So X would be, maybe you can replace all the values later. So you would have to add all those times in the seconds. Number of APIs handled by a single thread would be 1,000, or like this is again converted into like this is the reciprocal of like X only, converted into the seconds. Concurrent threads, again, like this concurrent threads, like I think in the last session also we have talked about that. If you are not aware how the thread and core works, whether like having multiple cores add some like relaxation in terms of processing or time, don't consider that, but it's just the figure that you can multiply. If one core is operated and it is adding like it has some like it is adding some complexity, then having two core would reduce the complexity, because multi-thread system would be like very beneficial here. It would be more performant with number of cores. So as of now, like in this bracket, you see that there is no hotspot because we do not come up with any such use case where we have to consider the hotspots. So it's fine. You do not consider that because we already have considered no limitation on the connection. So no celebrity or nothing kind of that we are assuming here, considering everyone can have any number of connections. Operating like they are operated for with some 30 or 40%. Okay, so this is generally a use case whenever you make some calculation, don't go with that like 100% of the capacity is being used. So whatever the calculation that you came up with, you just have to consider the fact that they are engaged with other processes as well. So maybe 30 or 40% of the capacity that is being used. Okay, and finally you would come up with the like dividing the Z by X, you would come up with the number of servers. Overall, what we have achieved here is that for throughput, we are given, we can we have made the assumption that how many number of queries per second. We know that how much each query, like each API or the algorithm would take. So considering the total time, like we know that total time would be how much would it be in seconds, and given how much time API, how many APIs hits we will have. So total time we would come up with, and number of API can be handled we are given. So it relates that if one server is able to handle limited number of API hits, okay, that means if it is exceeding some number of API hits, then we have to divide that load into multiple servers. Okay, so using that fact, we are coming up with the number of servers. One other way can be like considering. So here we have considered the throughput, considering the data amount of data generated. I think we have discussed the data generation part last time. So if we are given like we have number of queries, which we know these many queries we have, and each query is going to generate some data. So that data generated would like in a year or in a month, if it is generating some amount of data, that means if it is coming out to be something like 2 or like 5 TB to 10 TB, then we have to think about dividing that data into multiple servers. So that can be the other factor that is the key decision maker for coming up with the scalability here. Okay, I think Pradeep, Abhishek, you have question.
No, I will just lower the hand.
Okay, sure.
Yeah, same here. Sorry.
Okay, no issues. Actually, I was not looking at the chat, so okay. So in this way, maybe last time, okay. So last time, did you get the slides and you try to practice on the figures that like estimations and figures calculations? Did you find any challenges there? So here the same pattern would be used wherever you have to scale for throughput, given how much a query, how much time a query can take, and given the number of requests that would that we will have for this system. In that case, you can always come up with like with these calculation. So this data, either it would be given or you have to assume this data, you have to assume rest all is going to be the like same calculations. You can remember like if we are using one core, calculations would be different. Having multiple core would again affect that. Then operating capacity. So like you always have to take not more than 50% of the capacity, but it's optional. It come up with the experience only. So we have added that because we have heard from the from the interviews of like architects who were asked about these. Would why would you consider that one server is fully available? So based on that fact, we have added these points. Like these are important if you have like more number of years of experience and you have to consider most of the facts. So that is the reason. So this is part of like experience. So maybe you can add that if you are targeting some role like architect or technical program manager. then you have to add these points. For storage, probably we can avoid the exact calculation based on like what is the number that is there, and we can have it in variables only. Okay, so all you have to remember is that the amount of data generated, if it is exceeding in TBs, then you have to like you can simply divide that number of TB of data that is generated, divide by like 5 to 8. Maybe you can consider 5 TB per server. Divide the whole, like it is generating like 100 TB. Divide by 5, that many number of servers you would need. Okay. And similarly for cache as well, for again for cache, like this all together, like cache we generally come up at later point of time where we actually identify whether the caching is required or not, or how much caching is required. So caching for like all data is required or just the active data is required. So on that basis we take the decision. One way could be, let's say, number of connections created per day. So that can be one dimension. So per day, if like maybe 1 million users are creating like approximately hundreds of connections every day, then you have to consider how much data is generated. Out of that data, like last 5 days of data, we have to calculate how much data is generated, and that would sit into cache. Okay, this use case, I don't see it I don't see it much useful, the active data or the recent data, because for connections, one user can like look into any connection and he will have to query for those connections. So maybe the recent data is not much useful here, but uh, maybe something like who are the influencer who are creating the content, their data might be sitting in the cache, would be more meaningful. So you can consider all those facts, but then you have to accordingly change your use cases. So if you are considering recent data, then you have to consider how much connections are created per day. If you are making use of the influencers data, so active user who is actively creating the content, then you have to keep track of like how much data is being created recently, so that you have at least the users who are active. So maybe active users you can have, and their connections you can put into the cache. So accordingly you can make the changes. How would you figure out that how much data to be created? So let's say like 1 million users were active, and on an average they have like uh, zero point 0.5 million connections on an average. One may have like tens of million, one may have like little less number of connections. So assuming 0.5 millions of connections, so zero point 0.5 million times the number of active users, that is going to be the total uh, like activity that you will have. So per activity, how much data that you are storing. Maybe creating a connection would simply have user ID, the connection connected, so to user ID, the timestamp, and maybe some little bit of more metadata would be required. So that much data is generated. Maybe it would be in bytes. So bytes of data is generated times the total activity that has been, total number of connections that has been created or affected. So that all you would store in data. Suppose that is coming out to be like 2 or 5 GB per day. So in 5 days, like for active users, 5 days of data is come out to be like 25 GB. That can be in the cache. So there would be no issue. So that is easy to scale. So, but if it is coming out to be more than like 100 GB, then you can say that one cache server can have like 30, 40, 50 GBs of data for efficient caching. Then you can split that data into multiple cache servers. So this is the idea that I'm presenting here. For parallelization, so do you think any parallelization is required here? API parallelization would be required probably for third degree connection. When we say that we have to iterate to each of the connection of first user and check whether it's second degree or not. Maybe some parallelization we can apply there. Okay. So I think Ranbir, you have one question. Let me know. So any idea that you have, Ranbir? I see your hand raised.
I think we can spawn thread for each like first, second, or third level connection, right? So, you already said that.
Sorry, could you repeat what?
For API parallelization, I think we can process parallelly
Mhm.
first degree, right? Connection, a second degree, and third degree connection.
So
They,
first degree connections algorithm that we have decided is just lookup. So it would be good if only one thread process the whole list. Otherwise, if multiple threads try to read into the single memory location, may cause some issue. But the third degree, where we are iterating to each of the connection and making the decision whether something is present here, present here, present here. Okay. And then finally we are clubbing everything. Then that is the thing that we can parallelize.
okay.
Yep.
Uh, and my question was actually I wanted to ask earlier. So yeah, you said that if we don't know, it's okay. Like, what is the relation between core and max number of threads? Do we need to explore that more, or
You don't have to explore that. It's like you can consider it as CPU only. So within
okay,
that machine, so same machine is there. So you can consider like different cores, like they operate at similar speed. So it's like multi-processing system. Okay, multiple processing system. If you enable more core, it would be more efficient. So you are making use of the CPU usage to the optimal. Like we can use like up to 2 to 4 for efficient usage for like existing systems that we have. Okay, and
okay,
thread is basically the need that we have. So if we wants to so you know that every API call operates on different thread. It will create a different thread, and that thread is responsible for the whole life cycle of the flow of the data, flow of the control. Okay, so separate thread is created. If we wants to operate for single thread, then we have to use one something like queue, where each request would push something. The same thread would go and process something, return it back. Now it will pick something else and return it back. Instead, we have the request, use one thread to process this request. Meanwhile, second request come, the other thread would be responsible for that. So having multi-thread system is, I won't guarantee any like any kind of like more optimization there, but yeah, the CPU, we have the CPU idle time. So if CPU have looking for some data, it is waiting for that. When the async call is complete, it will come back. So this is the time where CPU is idle. So that time is being used by other thread, so it will continue in between. So that is for the like multi-threaded system. It removes the CPU idle time that we have.
uh, right, correct. And
Mhm.
how we can identify that how many max thread I can spawn, right? Number of maximum thread, right? In Java, right? Uh, I have one CPU.
Mhm.
Uh, then how we can decide that how many number of maximum thread we can parallelly spawn?
This is purely experimental.
Okay, okay,
Okay, generally like 100 thread would like in most of the application 100 thread would give you the efficiency, but more than that it will actually reduce the efficiency. So experimentally maybe like 50 in some system you would have the maximum efficiency, but it completely depends on what your implementation is. So for that implementation you have to have like you have to use some tools like perf monitor how your like CPU usage is in case of multiple threads. What is the expectation you have in terms of like data output and how the data is being like how the data is processed in the presence of multiple threads or in some few of the threads. So it's experimental.
okay. I think it's clear. Thank you so much.
Chandan, do you have question? Chandan, I see your hand raised. Could you please speak like what your question is?
Hello.
Yeah,
Hey,
I can hear you.
Rohit here. I may have joined in to a link shared by Chandan because my link was not working.
Okay.
He, I apologize if this has been discussed earlier. The problem is, given the number of connections, find the first, second, and third degree, right? Now, these connections are only going to be added, right? These connections are never going to be removed, right?
We are not considering the removal of the connection, at least at this point of time, because connection removal is very like limited. So we just omitted that. But yeah, like use case would be same here. There would be some connection that would be removed, and accordingly the list that exists. So this list is going to be updated. So one of the user would be removed from here. Okay, but finally we would have the list.
Correct. So if the connections are going to be append only, right? That's you're only going to add. The functional requirement says we are only going to add new connections, right?
Yes.
Then at every point of time when a new connection is added, we don't have to recompute all the connections, right? We only have to recompute the delta connections, right?
Yes. Correct.
Okay. And that's where we could leverage caching.
Yes.
Okay. Thanks.
Yeah. Okay. So we will take a little bit of break here. I think my system is again going slow, so maybe we can come back in like 5-10 minutes, and I will fix that. Though I know that we don't require break at this point of time, but it's fine. We can like cover in like in second session we can cover everything and we can wrap this session up. So maybe we can take like 5-10 minutes of break, and I'll let you know over the chat. And meanwhile, if you have any question, let me know. We can discuss after joining back. Okay. Okay, great. So everyone is back. So for storage, the idea that we will discuss like that. So probably you have to go some extra steps to calculate the data generated for each of the connection creation. And accordingly, you can decide whether you have to go with how many servers you have to go with, and given that you have the number of API calls. Okay, so API calls doesn't matter because these are for read. These will get the number of these will get specific requirements that is given in the functional ones, but for storage, the data generated, you have to calculate out of the box. API parallelization. So again, it would be similar to the throughput only, where you have number of APIs, and given that one API would take some time, so all the APIs would take the combination of that time. And what is the expectation? So we have been given that the latency should be the API should respond in some particular time. Let's say. So it was given like every API should respond, like API call should be responded in some like 100, like 50 milliseconds only. So in that case, if one of our API was exceeding that time, so maybe one of the API, that is say third degree connection, it was exceeding that time, it's taking more than 50 milliseconds. What we can do is that we can parallelize that, and we cannot comment on how much how much time it would be reduced, but it will definitely reduce the number of times. And there is one more relation that you can get here, like how many threads with how many threads you would get how many number of servers. So these calculation also you can use, but these are based on the fact that if you have doubled the number of threads, the time taken by each is going to be reduced. Okay, maybe there is no direct relation, but unless you have like limited number of thread increase. So if you are increasing the threads to say 4 or 5 or up to 10, then you can expect the time would be reduced by the same factor. But beyond that, it is not going to it will not reduce the time as we increase the number of threads. let's say if say increasing the thread from 2 to 4 reduce the time by make the time half, but increasing from 10 to 20 may not result in the same. So these calculation would hold good for like limited number of thread for one API call. Yes, they holds good. Okay, so you would know like number of servers that would be required. Okay, in this way you can calculate. Then we have throughput. So sequential IO throughput. So single thread provide, like as we discussed, it can provide that megabytes operations. We consider some value. A single thread can provide like 1-2 Gbps throughput, like for faster servers. Okay, and in this way, like for throughput, it's really not important. We just have included because these are use cases, but have not been asked anywhere. Okay, so you can go through that. The main part here would be the discussion on the sharding part, how exactly you are going to store that data, manipulate that data. So probably we can come back to these estimations, this particular slide a little later. Let's discuss about the high level architecture and how the sharding would take in place. So architecture is the same way that we have discussed, with few changes. Okay, so the load balancer is going to be the same, application server, they are going to be the same. There would be configuration manager, the cluster monitor, C1 is the cluster monitor, and there is config manager. Cluster monitor is like mainly for managing, adding, removing the cluster, reading the heartbeats. C2, the configuration manager, it will hold some configuration, as well as it can hold the reverse proxy as well. What is reverse proxy? It's kind of reverse indexing. So if we are using the sharding technique, which we will discuss in coming slides, if you are using the sharding, then you would have a number of shards that would be created. So if we are looking for like some data that will be present in some shards, then we can have this data present in the form of configuration, so that we don't have to look to all the servers. We can optimize that. So if say 100 servers or shards are created, then you can cut down the iteration to like rest of the shards and put those configuration in like configuration manager only. So if you're requesting for connections from some range of users, and you know that these would exist in some particular shards, then put them into the configuration manager, and those would be part of like the API's header or in the body, and add as a filter in the servers. Okay, so that is where the configuration manager, like it helps there. Okay, and again the C2 is like more closer to load balancer as well as application layer. So application layer can also be connected, and load balancer can also be connected to that. uh, Moving to next, and the similar kind of architecture would be there for storage as well and for cache as well if required. So they both will have the load balancer. If applicable, they will have the application or database server. Okay, now we know that a lot of data is generated by 600 million users. So definitely we have to think about how we are going to structure and store this data. Like we know that sharding like would play a good role here, because what sharding do is that, so I will repeat once again here. So sharding would simplify the calls that we are making. So if we have lot of data generated, which is kind of unstructured, so here the connections are there. So user one would have like lot of data would be here, user two would have lot of data. Plus we have to store some information related to the connections as well, how they are connected. So if user two is having some connection, some connections are deleted. So this would be updated here, and some replication would also be there. But having the data for 600 million users, plus for fault tolerance, we should be like replicating this data. It would be huge to query. So what we can do, we can simply divide this data into like multiple servers, assign some range, So like on a rough idea here, I'm saying that one 10,000 users, the data would be present here and so on. Data would be present here. But would this be any like good choice here? Sharding the data on the basis of the user IDs that we have. Okay, may not be. We will look how exactly we can optimize that. But definitely in one server is not going to help with this kind of queries. We have to have multiple servers holding different set of data. Okay, so moving forward, like we would have multiple choices here how we can store this data. One way is that horizontal partitioning, but or one other way is that vertical partitioning. Horizontally, that the main idea here is that we partition by key. Okay, so what it means is that the same we have discussed. So we have the users and they have the ID. Okay, so key. So for some range of users, user 1 to user 10K would sit here. Next set of users would sit here. Next set of users would here. So all the users would be present in different shards, but the data would be like data present would be same here. So if user have some data like connection list, then all the users would have connection list. No compromise on that. So this is the horizontal partitioning that we have discussed. So in vertical partitioning, it's little bit of different. It's bit of difference here. So what we do is that we have the users and let's say it has n number of connections. Okay. So let's name them. So one would be there, 2, 3, 4, 5. These are users only. Like this is a user. These all are all also users. User 2 would have like 2 is the user. So one would be there, 5, 6, 9, 10. All they are users only. So instead of storing the whole user into one table, what we can do is that we can use the values. Okay, values into particular shards. So like here, these values can be users can be part of like one particular shard. Okay, so this set of users can be in one particular shard, and there would be the information present. This user is the output from which user? User 2. So user 2 would be here. So all the information would be here. But the users that are present, they would be present here. So if one is repeated, so sorry, so let's say user 3 would also, one cannot be its own like for connection. So user 3 is here. Again, it is user 1. So this user appear 2 times. So what we can store is that in one particular shard, user 1 is present and it is the follower of which all users? User 1, user 3. So user 1 is the follower, user 2 and 3. So we know that user 1 is present here. Okay, and similarly, let's say user 5 to 5K are present here. So we'll have the information related to which all are the connections, like this user 5 is the output of which all connections. Okay, so in that way we can store. So these are two approaches. Both have like pros and cons. This looks good, easy to understand. Uh, and also similar kind of performance would be here if we store, because anyway we are going to store the users and their connection, and the same way user and its followers are present here. Okay. So Ranveer is asking partitioning is different than scaling. So Ranveer, yes, the partitioning and scaling are different. The question could be like partitioning and sharding, are they related or they are like not related? So scaling is something where we just have to scale our solution. So if one database is not able to handle the load, the data, then we have to split into multiple. So this is scaling. One server is not able to handle the number of requests per second, then we have to split into multiple servers. This is scaling. Similarly, for caching as well, if cache is very important and one cache server is not able to hold that much amount of cache, then we have to split into multiple caches. Okay, so this is the scaling where the somehow the server or database is not able to handle the load or request or the data, then we have to split so that we can, the system is available, but there is no single point of failure or single connection for that. So this is scaling where we simply just scale our application. This is a perfect term. We scale our application. Partitioning is like, it's a virtual partitioning. So like for sharding and partitioning, the word is used interchangeably, but there are differences. So partitioning would be like if we have storage here and it stores some data, then you know the concept of normalizing. So one table is split into multiple smaller tables because the querying to smaller table is much easier as compared to querying in a bigger table as a giant query. It's more complex. So having the query split into two multiple queries, then it would be simpler. So this is partitioning. But partitioning in multiple servers would be sharding only. Okay, so we group. So this vertical partitioning, like these two way of sharding only. But if somehow we are splitting the data into multiple servers instead of like within the server on the basis of keys, then it is going to be like sharding. So you can use interchangeably, but little bit of difference. So partitioning can be within one cluster, normalizing the data, normalized data. But if multiple servers are involved, then it's shard. We call it sharding only. So these two approaches, uh, like again, they have like performance wise, mostly they are same, but there may be different use cases. Uh, they're like interchangeably, they can be used. The place where we are using like this logic, vertical partitioning, it can be replaced by the horizontal partitioning as well. So accordingly, the logic would change and the indexing part would change. The only difference here is that we are storing the users in a vertical way, and their connection info would be there. So if we look into next slide, which would clear this a little bit, let me uh, delete my drawings from here. Okay. So here, let's say user one. So these are the users and like members, users. So they have these connections. So 5 is the common connection, 10 is the common connection, 8 is common connection. So multiple users are there. So they have member 1, 2, and 3. So these are 1, 2, 3. They are like kind of keys, but the data is not present in one shard. So considering the use case, the second use case where we are sharding, sharding on the basis of the value, not key. So member 1 would have data present in shard 0, 1, 2, and 3. So because the shard is based on the value, so one user will have all the followers present in different shards. So 8 is present in shard 0. So we discussed 8 would only be present only once, right? So if this is shard 0, so 8 is present one, but somehow there is some other table. It knows that users 1 connection is present in shard 0 and user two's connection is also present in shard 0. Maybe this mapping is present in configuration manager. So the number of shards the data would be present would be something like, let's say 10 shards the data is present. So and we know that the number also. So shard 0 is there, shard 1 would be there, shard 4 is there, maybe something like that for user 1. For user 2, data is present in shard 0, shard 5, and shard 6, for example. So from the mapping itself, without even iterating to the data, we know that we only have to look in the common shard, right? We will look into common shard and no other shard is common. So in these shards, whichever data is present, so currently it's 8 present, there may be multiple data would be present. So we will only look into shard 1. So if say 10K connections, shared connections are present in shard 0, which is higher number, then we trim down our approach to maybe hundreds of servers to just one shard. So we'll only look into that. So this is the optimization that we reached here. Okay. We will simply look into this particular shard or couple of shards for finding, for knowing where exactly we have to look for the data. Okay. So from 100 to like few bunch of servers, we will look for the data. So this is the difference that we have in vertical or horizontal. So in horizontal sharding, maybe for different users, you just have to jump to that particular shard, and we just have to look for all the data there. So if user uh, in that approach, if user one's data is present in shard 0, then all the data would be present in this shard only. So in the worst case, maybe possible that it has like 5K users data present in this particular shard, and somehow the connections has grown a lot overnight. It reached this server, this shard reached to 80% of its capacity. Now overnight something happened, and all the connections that were present in this particular shard, they grew like anything. So in that case, this shard would not be able to handle that much load. And again, that this has to be split into multiple other shards. Okay. So shard 0 would have like shard 0 dash and shard 0 double dash. So it will be split into two shards. The worst case that I'm talking. But in case of sharding by value, it won't affect, it will not be affecting, because it's kind of user is having the data that is the data present for users would be split, like it would be very consistent. It would not exceed in one particular shard, and if exceed, then it's just shard. So maybe we can simply have more values present in the copy of that. Both shard would represent, both the servers would represent one shard only. They will not be renamed to shard 0 dash or double dash. They would be one shard only. Look into this one and look into this one. So this is something that is the use case why we are going with like vertical shards, why not horizontal, or maybe like both of the choices has their pros and cons. But in the actual case study that have been published, many of the like such kind of platforms use this kind of technique. So that is why it's like it's reasonable, because it's experimental and it is in prod for many of the existing systems. So any question on that? I know we covered a lot here, and definitely there would be some question arise. So Manjinder, you have one question. Probably you can talk here. So let me ask for unmuting. Yeah, please like present
Yeah.
your question to everyone.
Hello. Yeah. Can you hear me?
Yeah, can hear.
Yeah. Yeah. So my question was to ask, like, while storing these values in the shards, so we are storing the keys also, right? If we want to know if this 8 is belongs to M1 or not, so it means we are storing the keys also along with the values.
Yes.
Yeah. Right?
So some metadata would be here. In
Yeah.
some bytes, data would be here. Yes. But
And
idea here
mm,
is that we are trying to simplify the online system. So we are doing the whole batch processing so that online query becomes more simplified. For that, even if if we compromise to store more data more than required, it's perfectly fine unless we are optimizing something, which is important.
mhm.
Yeah. So when for user 1 and 2, when you actually go into shard 0, because by that time some mapping would be stored in the cluster manager, that for 1 and 2 the data is present in these all shards, and we know that what are the common shards. We came to know shard 0 is common. So when you actually go into shard 0, then you would see that 8 is the user that is present here, and it is the connection of which other users. So that mapping may be present here, or that mapping can be taken from the list which is like original list from where this data is being sharded. Okay, so better idea is to store here itself, because this is the way that we have structured this data in this format.
Mhm. Yeah,
Okay,
thanks.
is it clear?
Yeah, it's clear.
Okay. Subramaniam, I think you have one question.
Yeah, actually, what I see is shard 0, shard 1, shard 2, shard 3 are value based. That is, it is member ID based. Divided by 4, whereas remainder 0, shard 0, and remainder 1 is shard 1, remainder 3 is shard 3, shard 2,
Yes.
and remainder.
Yes.
That is the way it is done. So, nowhere relationships are retained here. It is only vertical sharding is based on the member ID. Am I correct?
So, value, yes. So these values.
Viewer values. Values is nothing but it is user 1, user 2, user 3. That's all.
Yes. These are users only.
Yeah, fine.
User 2.
So it is not relationship based sharding. Horizontal shardings are relationship based sharding, correct?
Yeah. So for whole user, the data would be present in particular shard.
Okay, thanks.
Yeah. And here it's like, for example only, here it is present that it is going to have limited number of shards, static shards. But in actual, we go with dynamic shards. So one shard can be increased, one shard can be deleted if no data is there, and we will use consistent hashing in that. Just for example, here it is presented in this way, but idea is same. So consistent hashing would be used here. Almost in every problem you can discuss about the consistent hashing is being used for sharding 100% of the time, because nowhere we use the like static shards. Even if it is possible, then also we go with the dynamic shards. Even though for 10 years the number of shard would remain same, but go with dynamic shards and use consistent hashing instead of this. This is just for example here, so that we can visualize 4 shards are there. Okay. Okay, then I think I made it clear. If you guys have any question, let me know. Pradeep, you have question.
Hi Prashant, one question is like we have not received this PPT. Just want to confirm if anyone have received this PPT or not. Last time you said you will share, but it's not there with us.
I think it was shared. Could anyone please confirm? Hmm, Okay, maybe if it is not, then I will share it once again. Oh, Arjit, you did not receive. I will ask operation to share it immediately and also acknowledge the same to me, because last time I forwarded the slides that were there. So must have been shared.
So I checked my emails, I checked the system, it's not there in the. uh, So how do you figure out actually? We'll get attachment in the email, right? Or in the system, in the additional material we'll see, right? But
I
it's not.
think in the additional material you would get those slides. Ideally, even before the session, you should get the slides 2 days
Yeah,
or 5 days back.
yeah.
Okay, did you check everywhere, like in the resources?
Yeah, I checked it actually in the library, in the additional sources, in the notes. Nothing is there.
Oh, so could anyone please confirm if others get those slides? Okay, I will ask the operation to forward those slides like as
Well,
soon as
am I
possible.
audible?
Yes, you are audible, Abhishek.
Okay, I see there is one slide being shared in the last. It is there in the up level itself, but
Where,
it is uploaded in the drive as well.
where
In our
exactly?
up level, you go to our. Let me tell you exactly. You go to our 11th December class, last class. There, open it, and left side you will have resources where the one list is there which is saying slide. Helpful resources is there. There is a class slides part 01.
Just a minute. Yeah, I've gone to now 11th December. So there,
Yes.
Left side we are resources, right? Live batch video.
Helpful resources is there. One is primary resource, and then which is the video. Before that, there is a live batch processing class slide part 01.
Correct.
If you click
Yes.
on that, it will go to the link, which is a Google Drive link. If you open that, you should have a slide. I think you are looking for this slide or something else that you confirm to him, to Prashant. Then either he need to send again or whatever. One slide is available.
Okay, only one
That is a
slide. Okay,
batch processing slide.
Okay, part one slides are available.
Yes, and there is another slide also available, which let me see. That is a batch processing again. There are two
Correct.
slides actually now.
You can see now 2 slides are there.
Yes. So maybe you are looking for this one, these one of these two. Hmm? This is what we discussed last time, so I remember.
Correct.
Prashant's name is all done in that, right? So I
Yeah.
think you have this one. Then just cross check and then update Prashant. Yeah, thanks, Prashant.
Yeah, these I can see now. Thanks.
Okay.
I was searching in the library actually in the additional resources.
So library is what you actually mark as a favorite, and then it starts showing up there.
Okay. Thank you very much.
Yeah,
Okay,
most welcome.
thank you. So any other question apart from that? Okay, and I also shared one resources with the books and some other tips. Did you guys receive that mail?
Email you mean to say?
It should be coming with your name or from the Kickstart
From the
emails.
operations, yeah, Kickstart email.
No,
I
we
think
didn't
we
receive.
haven't. Let me check once.
Okay.
As far as I remember, it might have gone here and there. Let me check. So it should be again the same 11th December somewhere, right?
Yep. Okay, if you haven't received, no worries. I will share it once again. So today it
I
would be
think we
available.
haven't received. Maybe you
Okay.
can just help us getting it again. Thank you.
Okay, sure. So, so taking a pause here from all these slides and want to discuss about like approaching for the interview. And I think let's take one question from Subramanian, who have one question. I think your hand is raised. So
Sorry, I just got to analyze. I'll do it.
okay, no worries. So last time we have we discussed about like what is the framework for solving any system design interview kind of approach. So did you guys have any question on that, like how to manage the time, what how much time should be given for particular section of the interview? So any question on that, because lot of question occurs like how much time we should be spending on functional requirements and how much time we should be spending on the deep dive of the microservices. So I would tell like most of the time because
Yeah.
one query so you have any question?
Yeah. So one thing, I mean, as you are telling overall, that's good. But one more thing, like, what is the most important aspect in this entire thing, or in the sequence? Like, if we know the priority of the things, then we could focus on that stuff more and then lower down.
Okay. So priority wise, it's important if we focus on the parts like functional requirements, APIs, and the schema. Okay, these are like critical. And then anyways, the scalability part. What is the key factor that make us decide to go with scaling the application? So these are the four things. So first is the functional requirements. Maybe in non-functional, you can skip something if somehow you forget something. APIs, very important. maybe the top priority in the mind while approaching from starting from functional requirement till that point. Schema, we always store the data. Okay. Sometimes the data stored is like very simple. It's it's like storing some bunch of things only. So maybe here for like subsystem, we are discussing about the connections of the LinkedIn. So how much data that we will store. Okay. So here it was not important because we were given that we already have the connection stored. But if somehow you wants to interviewer wants you to discuss on the schema part, then it would be something like for users, you would have one table. You would have for connection. Okay. You would have some field like ID. Okay. Some other meta fields, maybe some other information about the users, maybe date of birth and all. Like right now it's not important, but you can mention about the like data or like or maybe about the education qualifications and all for this kind of platform. Connections, you would have user one, like you would have the users IDs. Okay. One particular connection would have one entry. Okay. Timestamp it would store. Okay. So for one user, how much data that we are storing? Maybe 0.1 KB of data we are storing. For one connection, probably same amount of data and even less. Let's consider it 0.25 KB and 0.1 KB of data that we are storing. So this data is important. Okay. And this discussing about the schema is important. So user ID, this is the foreign key for this particular one. But how much data that we are storing, it is only, we can only derive this once we have the schema that is available. So schema is like it doesn't depend on what type of data that you are database that you are using. Maybe it's SQL or no SQL that we are storing. Okay, so once you have presented the schema, then discuss about you are going with this one or this one. If you have strong need of consistency, go with this one. Else, most of the cases, we want the most highly available system. Go with this one. Easy to scale. NoSQL is easy to scale. Though there are databases that support the consistency as well, but having the consistency in the native as well as supporting the consistency, they are like two different stories. Okay, there's a strong need of consistency. Go with SQL. Else, go with this one. So you have to discuss about schema. You have to discuss about the like entry entry size, which is like how much data, and you have to discuss on the selection of DB. Okay, these three things are like key in the schema discussion. Okay, so yeah, this is what you will discuss finally, and then you can go with estimation if required. Otherwise, it's not necessary. You can always discuss like we have lot of data generated, and definitely one server is not going to handle that. So we would definitely require multiple servers to handle that data or handle that server if it is not able to handle the number of requests. Then you would come up with like scaling the data storage is required or not. You have like this much data, like this data like it's static, and this connection is keep on increase. Like every day you can assume some like 1 million connections are created or removed. They are like created. Maybe you can consider this connection creation. So each connection, like if user one is connected to like hundreds of users, then those 100 entries would be created, and imagine that number of users that are active. So 1 million, like 1 million of the connections are created every day. You can explain that as per your understanding or assumption, this much data would be created. So times 0.1 KB, how much data is generated, times 30, how much data is generated per month. If it is exceeding, like if it is coming out to be TB of data, like exceeding 5 TB of data, even in a year, 5 TB of data, monthly, if it is coming out to be like maybe 500 to 800 GB of data, shard this data. One server cannot hold this data for a long time. You have to shard that data. Then discuss about like why you are sharding, because you have like lot of storage generated, how you are sharding. Then you have to discuss whether you are going with which type of approach that you are going with, vertical or horizontal sharding, what is the benefit there, and like how it would ease the queries. So in like these batch processing system, these work behind the scenes, these just simplified the data. Maybe you have like 5 TB of data and structuring this data, and they have increased the data to 8 TB because they are again storing some metadata as well. It increased your data as well. But what about the online queries that you will get? It would be pretty fast because now you just have to look into some connection only. It's like looking as at these two shards for the connection shared by two users is like uh, is like 1 dB hit. So it's very simplified. Okay, so this is the optimization that have been achieved here. So all these things that you have to discuss, but focus like mostly on the part where you discuss about the functional requirements, API, schema, and then scalability. These are the key factors. Okay, and of course, coming up with the microservices, maybe there is no correctness there. Maybe you come up with like 2 microservice, you come up with 5 microservice, doesn't matter. Should be like 2 to 5 hours sufficient, and don't spend much of the time here. Okay, deep diving into microservices and these kind of discussions is important. So I hope you got the understanding where to focus more, but dedicate like 5 to 8 minutes initially at the start of the interview to ask question and answer. Get more clarity, what is the scope and what you should be focusing on. Sometimes it happens that the ask was towards the schema side, but person is focusing on the APIs and functional requirements, probably discussing about the architecture diagram. So diagram is not that important that you should spend most of your time. Okay, just having the diagram where you can like there is a client and it will call the application server, there is a load balancer, again there is a cluster manager which will hold the reverse mapping, then there will be multiple microservices. Okay, and maybe some queuing mechanism if you are using, it will have some consumers as well which will be impacted, and you can discuss about the storage would be there, it will be replicated or sharded. So don't spend much of the time in the architecture diagram. Have more practice so that you can draw it quickly if you are in the virtual interview. On pen and paper it would be easier. So architecture diagram is nothing but like you just have to discuss about the microservices, the cache that would be required, the database, and that is all. You just have to practice while designing. You have to keep explaining the things. So this is important, but don't spend like more than 5 minutes of time. More than that is not recommended. Always less time, because anyways, all the discussion would go into some of the microservices, or at most like 2 microservices. What would happen? Why you need the queuing and all these. So don't spend for drawing the architecture diagram. Okay. So yeah, this is all I wanted to discuss. And coming back to problem, so this that was important because we sometimes lose like when we have this kind of discussion where we deep dive into this system, and we did not discuss about the logical diagram, the microservices and other parts, but we did discuss about like deep dive into the microservice in this slide. So this is important, spend time here. So this is microservices architecture. Okay, and the caching is required where it is required, and the connections when they are like, we looked into the connection, and configuration manager is actually storing the shards. Okay, so that is configuration manager. For application, uh, if required, so here we have the API request, whether these are connected or not, that can be stored like very easily. It's just Boolean. Okay, that can be stored here. But if we had the requirement of getting the list of the connections, then it would be even more useful to have to store that many number of users as a connection. Here, it is like we can store like lot more cache here. Okay, so caching is required here, and caching would be updated time to time when the connections are updated, when the connections are created or deleted. Okay, so right now for this particular requirement, it will simply store U1, U2. This would be the key, and the value would be Boolean, true or false. And eviction policy, like when this data would be deleted from the cache on update, okay, or least frequently used. So update would happen on the actual update. Least frequently used would simply remove this data if this is not referred. Okay, so this was one thing, and we discussed about sharding, which is the important point here, how we are structuring the data. And now API flow. So once you have presented the APIs and you have presented your algorithm, so it would be like API flow. You can describe about that. Okay, so for different shard, because we have shards, how the data would be there. So mostly it's the configuration manager that would be storing the shards in which the data is present for user, which all shards. So connections would be in millions, but the shards would be in like hundreds or 200s of shards would be there. So instead of like iterating through the users, we will be iterating through the shards for finding the mutual shard. So mutual shard would have the mutual connections. So API call would be like same. It would like perform algorithm locally based on the data. It has like part list of the connection, some use cases that we have discussed, okay, while designing the brute force and the solution that was there, that when we have the list. So same applies here for shards. So for mutual shards, finding the mutual connection, mutual shards, two-pointer approach, shards would be, they would be in the sorted order, and finding the mutual shard would be two-pointer approach here. Then actually go into the shard and look for the data. Probably, I think you can mute if you are not speaking. So I will mute everyone. Just let me know if you have any question. Raise the hands. Okay, and finally we can like what is the benefit that we got here? So we can discuss about that, sharding and replication. So any like maybe I should be asking all of you guys whether there is any benefit for throughput. For shard with sharding, did we get any benefit of sharding in throughput? Or storage, any optimization that we face here? Probably yes for throughput if we have the sharding. For replication, yes. For storage, sharding has any benefit? Yes, we had. Replication, no. Okay, benefit like it would increase. And I think I would unmute everyone because I see the response in QA and I want the response, and like you can talk about if you have any question or you want to suggest. Okay, unmuted everyone, so all of you can contribute. Okay, what about the API latency? Anything like sharding has like did anything for latency, or application did for latency?
Yes, for both.
Okay. And then hotspots, I don't think we had any hotspots. We did not discuss anything here. But even like if we discuss the worst case for limited number of users, like maybe thousands of millions of users for limited number of users, connections for limited number of users. So what benefit, like, will there be any benefit from sharding and replication?
Yes,
Yes.
hotspot, yes.
Definitely yes. Okay, replication.
Yes.
Yes.
Yeah, makes sense, right? Geo distribution. We did not discuss this point in our slides. So like geo distribution, it would be important here.
Yes.
Okay. So sharding and replication, any impact on any positive impact here?
Yes.
Sharding, definitely yes. What about the replication? Yes, right? So
Yes.
if in one geolocation we have the shard present, the same replica is present in different geolocation. So it's replication, okay, but in different geolocation. But and this one is like making faster for to be available for one particular part of globe, and this one is making it easier for other part of the globe. So what about availability? Sharding did anything for availability?
No.
No. And what
Yes.
about correct? Yep. Okay. And what about the system? Is it consistent or available? It's more available, right? Okay.
Yeah.
So we have one suggestion from Gyan Rajan, which is consistent. Uh, okay. So Gyan Rajan, could you tell more like what may be the possible reasons of making it consistent, putting it consistent? Probably it's something like if some connection is created, do you think that this connection should immediately be reflected back to all the queries? I think this is not the requirement. Generally, when the connections are created, even like if other user do not see that connection, it's perfectly fine. In some time, it will be reflected. So that's the only reason we are not considering it as consistent. It's more available. So, guys, you might have got the polls as well. So, since we will conclude a little earlier, so you can fill the polls now. You can take time there. And Gyan Rajan, if you want to speak, you can speak also. I unmuted you. I see your comment on consistent in case of API latency and replication. Okay, so different aspect that you are talking about, but overall the system consistency I was talking about. So okay, okay, and so any question about like we started with the functional requirements, anything that we have not covered? Let me check here. Design a service that determines the degree connection between two members. So I just wanted to let you know that this was very specific question. So previously we had Instagram kind of like system design discussion we had, where we discussed mostly onto the news feeds, but we discussed all of the services. Okay. But if we have to discuss only for probably the news feeds only, okay, then in that case the requirement would narrow down, and we will discuss more on like how the feeds would be generated, how the feeds would be viewed. Okay. And if the focus is only on the feed generation, like how we structure the feeds, then it would be very much depth oriented, and we will discuss only the limited thing, mostly towards the data and the schema and the data side. How we make it more efficient to create the feeds for any user. That would be the main point of discussion. But in this kind of problem, uh, here we are well defined that we only have to focus on these APIs. Okay. And by the way, this question is not framed. It has been asked in multiple interviews. So we have taken that on voting basis. Okay. Exact question given these APIs. Okay. Because everyone knows the complexity. If we include more things, it would not fit into one hour of discussion. So it was not narrowed it down. Okay, but the same concept can be used in other platforms where you have the connections created, maybe connections of the users or maybe the resources. Even some similar kind of questions like were framed for like cloud as well, where different resources exist and they have the dependencies. So how would one know which all resources are to be collected by garbage collector, which all resources would still live idle even though they are not performing? Slightly different, but similar concept could be used there. Okay. And yes, so this is what we have discussed about, like the simplified approach here. But you can follow the same pattern. You will come up with functional requirements, non-functional requirements. Then you come up with the microservices. Here we discussed only one microservice, which is creating the connection. Okay, a connection generator. But you can discuss about, you can at least list down the view connection system, which is actual point of interest for the external world, because end of the day they just want to get the connection, they get their query to be processed. The other microservice would be the one that we have discussed. Then you can discuss about the schema, how much storage it would take. Then you can discuss about like deep APIs. Yes, API is already given, so you can list down the APIs. Then you can deep dive into microservice. You can discuss about the architecture which is there. So it, sorry, it creates this. So you can discuss about three-tier architecture would be here. Data model, you can discuss what exactly it is going to store. And the data model, you can like quote also whether it is required to have like how much data it is storing. Then you can discuss about the APIs. Logical diagram is not important for the microservice because there is one or two microservices only. Algorithms, yeah, it's important. At least you just go through the algorithm, how exactly it would work in like in one system. Okay, then when scaling, it would be deployed and we will scale based on different aspects. Then after we have defined the microservice, you have to take the decisions like what is causing this system to make it like scalable solution. While discussing about the algorithm, discuss about the complexity as well, or interviewer would also ask you what is the complexity. For scalability, you can mostly focus on these two things, storage as well as the cache storage. Okay, these are the important things. Storage, if required, you can always discuss about the storage in your own language, in your own simplified language, where you just discuss about how much data is generated and how much data each storage is able to handle. And also consider the amount generated times two, because you would be using their application as well. API parallelization, you can discuss, but it's not really required to have the calculations. Okay. But in what sense you can discuss? You can discuss about the idea of having the parallelism possible. So API 3 especially, it is making use of second degree, and all the connections can be operated independently. So that's why the parallelization can happen. We presented schema. We discuss about the scalability for storage, parallelization. One more thing that you can add is discussing about importance of like geolocation for scaling. Here it's much required. Yes, for different geolocation, it should be available. So that's why it should be present across the geolocation. So you would scale on the basis of that as well. IO throughput, if you remember, well and good, else not really required here. Estimation for storage, I told you about in the slide, and also the simplified way. This is important. So when you are done with like at least the schema part, then you can discuss about that. Probably you discuss about the algorithm and you discuss about the sharding as well. Then you can discuss like what this C1 is doing, what is the configuration manager is doing. So this configuration uh, is going to have the list of the shards in which user have the data. Okay, so 600 million users are there. Probably all of the data would be very much simplified and would be stored in like in multiple partitions here, and it would be in memory so that it's much faster. Okay, that would help to identify which shard to look into. This was the connection manager. And same diagram, you can use it as architecture diagram, or this one is also perfectly fine. No issues with that. API flow, or yeah, important thing. The flow of the system, like how your system is working, is important. So it's kind of dry run. When you complete one algorithmic question, you do a dry run. So once you are done with this kind of architecture, do a dry run. Like what happens when first time the data is coming and first time the data is queried. So discuss about that. This one, like you can present the example, like this one is good example. You can present in your own words. Then this one is not important. Like just for your understanding, the slide is being added, not important, but try to explain, if asked, try to explain in your words like how you are thinking about the sharding, because sharding is important in the scalable interviews where you are structuring the data for making the system fast. So it's important. So maybe you can present in your own words this particular thing. Okay, and you can take the reference, you can apply it anywhere in similar kind of questions. So yeah, this was all about the graphs that we discussed here. And this is all batch processing where we are mostly focused onto the solution, the schema and the databases, where because end of the day we have to simplify the data for online processing. So any question on that, like overall any question, or overall any question on anything, maybe the pattern, or like any situational based question, any role based question, experience, expectation, anything.
So one question I have, like in the for manager round, how many system design round usually we have in the Google or Amazon?
For manager, technical program manager or product manager?
Engineering manager.
Engineering manager. Okay. Uh, I appeared for such role, like interviewing such role, and at least two discussions were there. One was mostly focusing on the first part of it, the requirement gathering, because once you interacted with the customers, you have the requirements. You have to simplify them, and you are not required to connect again and again with the customers. So the functional and non-functional requirement part should be like very clear to you. So this was important, and coming up with the system, how many teams would work on, how many teams you would be leading. So the idea was to identify the microservices and the data storage, plus the capacity that you are being used. So how much is the cost that you may think of, how you would optimize the cost. So probably the ask was to identify like how closer you can have the teams, and that one team can handle how many number of interrelated microservices and the databases, plus the technology evaluation. It was also expected from the product manager. By the way, it was product manager role for like 15 years of experience. So they were asked about the like capacity estimation and technology evaluation. So given the situations, like probably we have this kind of system, some LinkedIn kind of system, and we have our own legacy system where everything is working, and we have to choose the new technology that is in the market. So how would you evaluate? Probably for a longer run, for the quick POC, how would you proceed with that? So there is no specific answer for that, but it just depends on your experience, how much exposure you have. Have you actually handled one team, or like you have been a leader in the past? So these all things that you have to consider. You have to like frame a story, or you have to explain as per your experience. So this is what expected from the product manager. In the next part, uh, some situations where you have to optimize the databases, something similar to what we have discussed here as part of sharding. So it was very specific, like given a very large table, how would you make it very fast? So it was like very subjective question. You don't know the details. You have to ask the question. You have to get the explanation. You have to get the clarification. What is the expectation here? Just one question is given. There is a very large table, and your system is becoming very slow day by day. So what would you do? So these type of questions have been asked from engineering manager, like at least in one of the interview discussion, and there are like two type of such discussion you can expect.
Yes. So how long shall we spend on gathering requirement? Probably 5-10 minutes. And shall we note down in a notebook, or shall we do screen sharing and write down those points so that it's visible to both of us, interviewer and the interview?
Yeah, it is good idea. Right now there are virtual interviews only, so writing down on the whiteboard is like a good approach here. Okay, so you can use OneNote. There are applications like OneNote, or like whiteboards are available online as well. So you can make use of the whiteboard and present there.
Yeah, Prashant, thanks for that. So also, if I had to schedule system with the interview with you, then how can I do that? Do I need to specify your name, or what shall I do?
Sorry, I think I missed something. Could you please repeat again? Your
In
voice was
case
like.
I want to schedule my system design interview with you,
Mhm.
do I need to specify your name, or what exactly I need? Because when we schedule the interview, sometimes names are not visible.
Okay, okay. Uh, Probably you can ask interviewer about the mock interviews. I'm not taking mock interviews at this point of time. At this time, I'm not taking, but probably in future, like if you schedule, we can look. Like, you just have to ask operations for that. You can post your query as well to them.
Okay, thanks, Prashant. How we can connect sometime to get your interview? Because I'm planning for Google Amazon interview, but
Mhm.
here asking so many questions might not be helpful to other. Actually, can we connect sometime?
Yeah, over the LinkedIn, we can connect. Like I will share for everyone. You can get connected to me. I'm mostly not active, but sometimes I'm active, so we can connect over there. Okay, I will share over the chat my LinkedIn URL. And Manjinder, you have one question: how to draw batch processing unit in Architect? Okay, could you please speak up? Okay, I didn't get the unit in Architect. I didn't get this point. You are asking
So
about
yeah,
drawing the architecture
yeah,
for the
yeah.
system?
If I want to show that there is a batch which is running behind the scenes, so what is the best way to show that in the diagram?
Yeah. So it is same as online processing, except that so there is one event would be there. So one service which is actually catching the event manager would be there, which will actually catching all the events. So connection is created, friend request is being sent, connection request sent, message is sent. So all such event would be there. This microservice would actually route different type of messages and the action to different queues. Okay. So if it is the message, or if it is something like, say this is for message, this is for connection. Okay. So different queues would be there. So what are the consumers of this? One is definitely the batch system. Okay. Other consumer would be the in the read we have something like we have the caches. So like we have to clear those cache or update those cache. Okay, so sorry, this would be the service. So there can be one service for like what we say update and cache update. Okay, so this would be the cache update. In the batch system, you would explain uh, everything about that. Like you will have the load balancer. Okay, this is the microservice which is actually triggering the job. So load balancer is not required. So there would be a queue which will have the actions queued and your microservice, the actual, or I think this one is repeated. So your microservice is going to read those particular actions and it is going to proceed in like in the application there. So this is the application there. It would be here. Okay, and it have the access to the cache. Okay, sorry, configuration manager that we have discussed. Configuration manager is there. So user to cluster shard mapping is here. So your batch processing system have the access to that. And mostly all of the things that you have, all the algorithm that you have, you can place it here. Then you can connect it to database that is present here. So database would be there. These are the shards would be here. Okay. Plus also it will be updating some cache, which is being used by this service, which is the read service here. It would be the read service. Okay. So this is kind of like very rough diagram, but you can always start with like client. It will have the load balancer. Okay. This load balancer would have the event manager, and event manager put the data into some queue. Don't use like many number of queues, because generally when we have the idea of queuing mechanism, we use the queues everywhere. So this load balancer would land to some event manager. This event manager would push the data to some queue, and from queue the batch processing system would take the data. In a single system, it is doing all the processing. So it will be storing to this database, final output. Then your read service is going to read that data, this structured data. It is going to read that data and present to the online system, online queries that we have. So key point here is that you should have this load balancer. You should have the microservices. You should have the queues because they are important. Every call will like will not be waiting for something. It will simply push the actions because the amount of data that is being generated is like thousands. And the best way is to keep the data in the queue. Just keep it and do something else. Okay. And even querying, like even having the get call would take more time than putting the data into the queue. So that's why queuing is being used here. Okay. And anyway, this application would be scaled because it's the event manager. So all will be accessing the same queue. Rest is the same story. Like batch processing is going to process that data in this way, and it will store the data into the database, and your read service is going to read the database. Okay. So these three, four points that you should be discussing. And once you have discussed about the sharding, then discuss about the configuration manager. What data would be here in the configuration manager?
So I was asking this question because let's say if I want to make a batch which triggers every night, let's say at 12 o'clock. So is it the responsibility of event manager to trigger that particular microservice which does that part of work?
No, it is not. It is not. So on scheduled jobs, let me have it here. When we have the scheduled jobs, there are two ways. One is based on the capacity, other is based on the time, and there can be other factors also, like when this job should be triggered. Okay, maybe some API call. Capacity, probably this queue have, let's say, some 10,000 events. Now it's the perfect time to to trigger the batch job. Other, in some time, every 2 hours or 5 hours, this job should be triggered. So for that, normally we have the web function. Okay, web function or lambda function or web job, whatever we call, any function that can simply have the access to reading this as well as reading this. This can be part of this batch system as well. One part of it is just querying and taking the decision whether it's a correct time or not. Okay, so for trigger, maybe it's time based, it's like query based, it's capacity based, but your batch is the responsibility of your batch system to identify when the batch should run. Okay, not the responsibility of event manager. Okay, because it has just, its responsibility is just to put the events. It's batch processing system's responsibility when to run it.
Mhm.
Okay. Okay. So we have covered pretty much everything now for this system. Probably next time when you are given some, uh, you will have some time test, I guess, next week. So in that, we can mostly focus on the points that I have discussed. If sharding is into the picture, then try to focus more onto that. Different ways, like caching is required or not. But start with the functional, non-functional, API design, schema design, and am I missing something? And the architecture of the microservice that is being used, plus the core algorithm, as well as the optimal approach for sharding. These all expectations would be there in the coming test sessions. So whatever be the problem, if it is depth oriented, then definitely these will be the points of discussion. Okay, guys. A last call. If you have any question, let me know. We can discuss, as we can simply wrap this session up. Okay. So considering silence is no question.
No, I'm good. Thank you.
Thank you, Abhishek. Thank you,
Bye.
everyone.
Thank
Bye.
you. Thank you, Prasan. Thank you, everyone.
Thank you. And
Wonderful
if you
feedback.
have any question, just reach out to operations. We can have the session scheduled. So no worries on that. You can always like ask them to connect with me or any of the like instructor.
Okay,
Yeah,
so
we'll
Okay,
do that.
great.
Great. Thank you, guys.
bye.
Thank you
Thank you.
for this
Thank
interactive
you.
session.
Bye.
Bye.